So this is the second part of the video for this section, and I'm going to do 20. It looks harder than anything we've been doing. Once you start throwing letters into the mix, I just think it's just inherently harder. Still have to do 4 multiplications to get problems 20 started. I can't do this on my calculator because of the x's. The multiplications I need are 3 times 5, so the 3 multiplied by both terms in the right parentheses, and 3 times minus square root of x. Usually I shove that minus in a parentheses. And then the same with the 2 square root of x. 2 square root of x times 5, and 2 square root of x times minus square root of x. Those are the 4 multiplications I need to do. First multiplication is just simple. It's 3 times 5, which is 15. Second multiplication, positive times a negative is a negative. I can't put the 3 under the radical because it's not under a radical, so I put it in front of the radical. Third multiplication, they're both positive, so I get a plus sign. I multiply the 2 and the 5 because they're both outside the radical, and I leave the x. Last multiplication, positive times negative is a negative. I leave the 2 in front of the radical, and I multiply the x's under the radical by adding the exponents. X times x is x squared. These 2 radicals don't reduce because there's only a single x under the radical, and to reduce I would need 2 x's. So I'm just going to combine these, and the numbers in front have opposite signs, so I'll subtract them. 10 minus 3 will give me positive 7. So part of my answer, the radical part, it was going to have 7 square root of x. The last piece, the x squared, it's a perfect reduction. If I did the prime factor tree, I get an x out in front of the radical, and there's nothing left over afterwards to put an x under the radical, so this last piece is just going to be minus 2x. These are all simplified, and none of these can be added or subtracted. To get to the point, if you're only in the adding and subtracting, you only can add or subtract if you have not only the same letter, but they'd have to be in the same position. This x, because it's not under the radical, can't be added or subtracted with that. So for 20, that would be my answer. Hopefully you can give 19 a go. I'll just keep kind of pouring through this section. It's long. 22 looks way harder than 21. Let's do 21 together. Pause the video, maybe try 21, and I'll do the multiplications for you. So in 21, I have to do cube root of 2 times 5 cube root of 2, and cube root of 2 times minus 6. And then with the 3, I have to do 3 times 5 cube root of 2, and 3 times minus 6. The cube roots make it so my calculator can't do this, but just give me decimals. First multiplication, I multiply the 2's and get a 4 under the radical, and I leave the 5 in front of the radical. That's not going to reduce because the prime factoring for 4 doesn't have a 3 of a kind, and in the cube root for the radical to reduce you need a 3 of a kind. So that first piece, this 5 cube root of 4, it's not going to reduce. It may not even combine with anything along the way. The middle multiplication is positive times negative, so I get a negative. I shouldn't get a 12 there. I can't multiply a number under a radical by a number outside a radical. And that radical won't reduce because 2 is a prime number. There's not a 3 of a kind in its prime factorization. Fourth multiplication, 3 times 5 is 15, and positive 15, and I leave the cube root of 2. These middle terms can be combined because they both have the same radical, and to combine them I just do 15 minus 6, and 15 minus 6 is positive 9, or I do minus 6 plus 15, it's also positive 9. So those terms that I boxed would be a 9 cube root of 2. Last, 3 times minus 6 is minus 18. I have 3 terms now written down, and none of these can be added or subtracted because to add or subtract, not only do you need the same index, you need the same radicand. So that would be the answer for 21. 23, it only has square roots and it doesn't have any variables or letters. My calculator can't do it. It's too big for its memory. I'll do 24. You can do 23. Usually I skip these because I don't have time in class. So let's go ahead and skip 25 and 26. But I just want to show you 24 and have you try 23. For 24, I have to take the 2 in the first parentheses and multiply it by all the terms in the right parentheses. So I have to take the 2 in the first parentheses, multiply it by the square root of 2. The 2 in the first parentheses, multiply it by the square root of 5. The 2 in the first parentheses, and multiply it by the 7. I have to do the same with the 3 square root of 10. I need to take the 3 square root of 10 in the first parentheses, multiply it by the square root of 2 in the second parentheses. The 3 square root of 10 in the first parentheses, multiply it by the square root of 5 in the second parentheses, and the 3 square root of 10 in the first parentheses, multiply it by the 7 in the second parentheses. Those are 6 multiplications that I need to do. The first multiplication, it's just 2 square root of 2. Second multiplication, plus 2 square root of 5. Neither one of these radicals reduce because 2 and 5 are prime numbers. There's no pairs in their prime factoring. Third multiplication, positive 14. Fourth multiplication, they're both positive, so I put a plus. I get 3 square root of 20. And the square root of 20 is reducible because the prime factoring for 20 is 2 times 2 times 5. So this third multiplication is really 3 times 2 square root of 5 because 20 reduces to a 2 out and a 5 under. So the third multiplication should be 6, or fourth multiplication should be 6 square root of 5. So what I have right now, the first multiplication was 2 square root of 2. Second multiplication was 2 square root of 5. Third multiplication plus 14. Fourth multiplication ultimately is plus 6 square root of 5, which is going to combine with that ultimately. Fifth multiplication, should I say, both plus. I leave the 3 out front and the 10 times 5 under get multiplied. I'll do a prime factoring for 50. 50 is 2 times 5 times 5. So for that multiplication, I get a 5 out and a 2 under. So for that second to last multiplication, the square root of 50 is going to reduce. I'm going to get a 5 out, then I'm going to multiply it by the 3 that's already there, and a 2 under. So that fifth multiplication is going to be 15 square root of 2. Last, I do multiply the 3 and 7, get positive 21, and I leave the square root of 10. And the square root of 10 is not reducible because 10 in its prime factoring doesn't have any pairs. So the 6 multiplications that I get are 2 square root of 2 plus 2 square root of 5 plus 14 plus 6 square root of 5 plus 15 square root of 2 plus 21 square root of 10. There's some terms that can be added. You can only add or subtract with radicals if you have the same index and the same radicand, and those that I just circled, the 2 square root of 2 and 15 square root of 2, add up to be 17 square root of 2. Similarly, this 2 square root of 5 and that 6 square root of 5 can add up to be 8 square root of 5. And nothing else, the 14 and the 21 square root of 10, can be combined by adding or subtracting, because when you're dealing with radicals, the radicands have to be the same in order to add or subtract. This would be a perfectly good answer. I don't know that I can write it different and make it better, but I don't know, I could write the piece without the square root first if I cared to. I don't know that that makes any difference. It's not any more or less correct than this. Here I've got the number without the square root first, and then the square root's going from smallest to biggest. You can shuffle these orders around any way you want. It doesn't matter. So give 23 a go, but go ahead and skip 25 unless you just feel like trying it. 27 through 36 are special problems, and 27, 28, 29, and 30, 27, 28, 29, and 30, these are all called conjugate pairs. And what I mean, or what a conjugate pair is, each parenthesis has two terms in it, and the terms are identical except one of the parentheses has a minus, the other has a plus. And when you're multiplying conjugate pairs, you get a lot of cancellation. And if you do enough conjugate pair multiplying, you can skip some of the multiplying. But I'll pretend like I don't know anything. I'll just do generic multiplication and do 28. To do 28 without recognizing that I could be slick, because maybe I don't know what being slick means yet, I'm going to take the 3 in the first parentheses, multiply it by the 3 in the second parentheses, take the 3 in the first parentheses, multiply it by the minus rad 6 in the second parentheses, and then the rad 6 in the first parentheses, multiply it by the 3 in the second parentheses, and the rad 6 in the first parentheses, multiply it by the minus rad 6. First multiplication, I multiply the 3's and get a 9. Second multiplication, positive times the negative is a negative. I shouldn't get an 18 because I can't multiply something outside a square root by something under a square root. Fourth multiplication, they're both positive, so I get a plus sign. I just leave the 3 in front of the radical, the 6 under the radical. Shouldn't get an 18. Last multiplication, positive times negative is a negative. Both the 6's are under the radical, so I'll multiply them to be a 36. Conjugate pairs always have this happen, that the middle part of your multiplying cancel, and you don't really have to do all 4 multiplications if you know that 2 of them are going to cancel. You can be slick in multiplying conjugate pairs. To finish this up, I canceled these because they're opposites. The 9 I brought down, and the square root of 36 I know to be 6, and this is just going to be 9 minus 6, which is going to be 3. The answer to problem 28 is just 3. Could have done it on my calculator. Did 3 plus square root of 6 times 3 minus square root of 6. And my calculator tells me that my 3 is perfect. I'll do 29 with you. You should do 27. 29, technically I should do 4 multiplications, but some of them are going to cancel, and I could be clever. 29, I should do x times x times minus square root of 7, positive square root of 7 times x, positive square root of 7 times minus square root of 7. First multiplication, x times x is just x squared. Second multiplication, positive times a negative is a negative, and the x is going to remain in front of the radical, the 7 is going to remain under the radical. Third multiplication, they're both positive, so I'll put a plus. The x is going to be outside the radical, the 7 is going to be under the radical. Last multiplication, positive times a negative is a negative. Both the 7's are under the radical, so I'm going to multiply them. And because these are conjugate pairs, I really don't need to do all 4 multiplications. If I could figure out ahead of time which ones are going to cancel, I can skip that, because always when you're multiplying conjugate pairs, which are 2 identical parentheses with 2 terms each, one parentheses with a minus sign, the other parentheses with a plus, doesn't matter which one has the plus, could be the first or the second, you always get canceling. And for an answer here, I'm going to bring down the x squared, and the square root of 49 is just 7, and I leave the minus in front of it. $31 looks way harder than $32, so I'll do $31. Why don't you pause the video and give it a try. It's also a conjugate pair. So in $31, I should do square root of 2 times square root of 2. If I'm clever, I don't do this next multiplication. The multiplication of square root of 2 times minus 3 square root of 5, along with this multiplication, 3 square root of 5 times square root of 2. Those are going to wind up canceling. The last multiplication, 3 square root of 5 times minus 3 square root of 5 I need to do. So first multiplication, rad 2 times rad 2, or square root of 2 times square root of 2 is the square root of 4. That's just 2. Middle multiplication, positive times negative is a negative. I leave the 3 in front of the radical. I multiply the 2 and 5 under the radical and get 3 square root of 10 or minus 3 square root of 10. The next multiplication, they're both positive. I leave the 3 in front of the radical. I multiply the 5 and the 2 and put them under the radical. Last multiplication, 3 times negative 3 is negative 9 in front of the radical. 5 times 5 under the radical is 25. Always when I'm multiplying conjugates, if I know ahead of time what's going to cancel, I don't need to do all 4 multiplications. The last piece here is just minus 9 times the square root of 25, which is minus 9 times 5. So what I have is 2 minus 45 for problem 31, and the answer to problem 31 is just going to be minus 43. 33, 34, 35, and 36 are perfect squares, are squaring of a binomial. These are tricky problems. You can't just square the numbers. In 33, I just can't square the 3 and square the 6 to get to the answer. Let's do 33 together. Let me get an answer for 33. 3 plus square root of 6, quantity squared. The answer for this should be 15 plus 6 square root of 6. If you just squared the 3 and got 9 and squared the square root of 6 and got the square root of 36, which is 6, you'd get 9 plus 6, which is 15. You'd miss this piece here. To do these last 4 problems, I need to write the problem without the square. And when I write it without the square, I don't change the signs. I get 2 identical parentheses with exactly the same sign. Sometimes when students expand to write these without the exponent, they change a sign, and that's wrong. So I'm going to write 33, 34, 35, and 36 with 2 parentheses, and then I'll do the 4 multiplications. Nothing's going to cancel. So here I'm going to do 3 times 3, 3 times square root of 6, square root of 6 times 3, square root of 6 times the square root of 6. First multiplication, 3 times 3 is 9. Second multiplication, they're both positive, and I leave the 3 and the 6 next to each other. Third multiplication, they're both positive. I leave the 3 and the square root of 6 next to each other. Last multiplication, both positive, and I multiply the 6's. The square root of 6 doesn't simplify because 6 is 2 times 3. There aren't any pairs. But those 2 terms right there, the 3 square root of 6 plus 3 square root of 6, give me the 6 square root of 6 in my answer. And to get the 15 in my answer, the 9 that's up front will combine with the square root of 36 because the square root of 36 is just 6. And that 9 and 6 give me the 15 for the 15 part of my answer. I could have written my answer as 6 square root of 6 plus 15. That wouldn't matter. The order doesn't matter, but I need those pieces. One last problem. You can do 35, I'll do 36. For 36, I need to write it as 4 plus 5 square root of x times 4 plus 5 square root of x. I'll do the multiplication of 4 times 4, 4 times 5 square root of x, 5 square root of x times 4, and 5 square root of x times 5 square root of x. First multiplication, I get a positive 16. Second multiplication, 20 square root of x. Square root of x doesn't reduce because that's just a single. Third multiplication, positive 20 square root of x. Fourth and last multiplication, I multiply the 5's in front of the radical and the x's under the radical and get 25 square root of x squared. These middle terms are like terms, they can be added, and to add those, I add the 20's and get 40 square root of x, and the last term, the square root of x squared, you get an x out in front of the radical, but there's no radical left over, so the last multiplication just gives me 25x. And That can't be combined with the term preceding it because when you have radicals, you could only add or subtract if you have the same radicand. You can't add a piece with a radical to a piece without a radical. So that would be the answer for 36. Should give 35 a go. So you should try to do all the odds in this section that I didn't do with you, and we'll just call it quits here.